Today, we are going to talk about Wilson's theorem. First, it states that p minus 1 factorial mod p is equals to negative 1 mod p. Example. Let us remember that p is a prime number. Let us use 7 since 7 is a prime number, and then we're going to substitute 7 into p. So now we have 7 minus 1 factorial mod 7 equals negative 1 mod 7. 7 minus 1 factorial is equals to 6 factorial mod 7 equals to negative 1 mod 7. Negative 1 mod 7 is equals to 6. So let us all bring down 6 factorial mod 7. And now remember that 6 factorial means 6 times 5 times 4 times 3 times 2 times 1, and that is 720 mod 7 equals 102. Why? Because 7 divides 720 is 102, in which it gives us a remainder of 6. And now let's try another example. We have 11 minus 1 factorial mod p equals negative 1 mod 11. And now we have 10 factorial mod 11 equals negative 1 mod 11. Negative 1 mod 11 equals 10. Factorial 10 mod 11 will give us a remainder of 10. We're going to erase that. Okay, so let's proceed. If we're going to do the factorial of 10, and we get 3,628,800 mod 11 is equals to 329,890, in which this will give us a remainder of 10. That's why we're going to use this theory so that we won't be able to deal with these large numbers. This time we're going to use another technique. This states that p minus 2 factorial mod p is equals to 1 mod p. Now we have 13 as our prime number. I'm going to substitute it. So 13 minus 2 factorial mod 13 is equals to 1 mod 13. 13 minus 2 factorial will become 11 factorial mod 13 and 1 mod 13. So let's remember that 1 is our remainder here. Okay, so again, 11 factorial mod 13 will give us a remainder of 1. And some of you might ask, where did the second rule or the second technique came from? So let us know by finding 11 mod 13 using p minus 1 factorial mod p minus 1 mod p. So our p is 13, so 13 minus 1 factorial mod 13 is equals to negative 1 mod 13. Now 13 minus 1 is 12 factorial. Mod 13 equals negative 1 mod 13. You have noticed that we have 12 factorial instead of 11. So to get this, we have to rewrite 11 mod 13. And how do we proceed? Note that factorial 12 means 12 times 11 times 10 until 1. So we have 12 times 11 factorial because we were going to find 11. 12 times 11 factorial mod 13 is equals to negative 1 mod 13. The next step we're going to do is to remove 12. But how do we remove 12? 12 will become negative 1 because 12 mod 13 is equals to negative 1 times 11 factorial mod 13 equals negative 1 mod 13. Okay, so now we have a problem, which is there are both negative 1 in the left side and the right side. To remove this, we are going to divide both. Negative 1 divided by negative 1 is 1, in which it will give us a remainder of 1. And now let us go back to the second example. Now, it has the same remainder. So, it states that p minus 2 factorial mod p is equals to 1 mod p. So, as you can see, we have 11 factorial mod 13 equals 1 mod 13 that gives us a remainder of 1.